All right, this is Math 209, Week 4. We're doing section 11.1. We're graphing quadratic functions, and I'm going to tell you in this whole set of videos, Desmos is going to be your friend. So make sure you go to desmos.com. So on this problem, we don't actually need Desmos quite yet, but we're going to get ready for it. And the idea is, on this question, if you want to find out f of 0 or f of 2, what that means is what is the value of the graph when x is 0, and what is the value of the graph when x is 2. And so we're going to go over here and we're going to look. And we can see that when x is 0, right here, y is down here at -3. All right, and then so that tells you that f of 0 is -3. They're saying when x is 0, y is -3. And what was the other one? F of 2. So now we're going to go back. Go over here, and so when x is 2 right here, so we're going to find f of 2, and so when x is 2, what is the y value? Well, the y value appears to be right here, which is 1. So those are your two answers that you're going to input into MyMathLab. Basically, when x was 0, y was, what is it, -3, and when x was 2, y was 1. And so that's what that is all about. Now this one we don't need Desmos yet either. Again, they're just asking what is the f of 2 and f of 3. So we're going to go over here to our graph and we're going to zoom in f of 2 and f of 3. So we want to know f of 2 and we want to know f of 3. And so when we look, well, let's start with f of 2. So we're going to look for 2 on the x-axis. It's right here. And we see that the y value appears to be 1. So it's going to be 1. And then for the next one, f of 3, we look for 3 on the x-axis. It's right here. And we go up, and it looks like the y value appears to be 2. And so that is what you're going to type into MyMathLab. All right, so when we are dealing with quadratics, your parabola, the curvy shape that we're dealing with is called a parabola. Oh, there it is, parabola. And that parabola is either going to be a smiley face or a frowny face. It's either going to open upward, in which case it's a smiley face, or it's going to open downward, in which case it's a frowny face. And so we can see that this one is definitely opening downward, so I'm going to circle that right now. Okay, there, it's opening downward. Now, what is the vertex? Now, the vertex is the maximum or the minimum on that graph. So when you have a graph, and I'll say, okay, let's say the graph is here. I mean, the grid is there, and let's say the vertex is like that, so it's a smiley face. So the vertex is the absolute minimum of that parabola, the very bottom of that parabola, or if it happens to be a frowny face parabola, then the vertex would be the absolute maximum of that parabola. So this and that are your vertices is how we say it, but your vertexes. So the vertex is your maximum or your minimum, depending on if you have a frowny face or if you have a smiley face. So when we look over here and we look at our graph right here, our graph, well, it's definitely a frowny face, so our vertex is going to be the maximum, and it looks like the maximum appears to be right there. So that vertex is at -3, 1. And that's what you would put in for your vertex. So the vertex is, negative 3, 1. All right. So we can just see it by inspection, just by looking at it. Now there is a nice, beautiful little formula that we can use to get that vertex, and I am going to show it to you in later problems. But at this point, if you can just see what the vertex is, go with it. Just use that. So choose the correct equation for the axis of symmetry. Now, the axis of symmetry is basically saying what we have is this parabola is always symmetrical. The left side is always going to be the same as the right side. And you can see that the axis of symmetry is right here. This is the line that cuts that parabola in half so that the left half is the same as the right half. And you'll notice it's right here at that negative 3. So this axis of symmetry is x equals negative 3. So your axis of symmetry is x equals negative 3. So a lot of vocabulary here. Vertex, that's going to be your maximum or minimum, depending on if you have a smiley face or a frowning face. Your axis of symmetry is where that mirror image occurs. And then you have to decide if it's going to open upward or downward. All right, so here's where Desmos is really going to come into play. It says identify the vertex and the axis of symmetry for this line down here. Now, what we can do, and then it says then graph the equation. Well, we can use Desmos to graph it first, all right, and then answer all the other questions. So when we use Desmos, we type in our equation, you immediately get this beautiful smiley face. So it's an upwards, it opens upward parabola. And you can see that the vertex is down here. In fact, if we kind of zoom in a little bit, you can see that the vertex is right here at 0, 0. So we don't have to do any math. We see that the vertex right away is at 0, 0. So our vertex, let's see, right here is at 0, 0. Now, there is a formula, and I need to show you the formula in case our vertex is not like this perfect, nice, beautiful, obvious answer. So the formula for finding the vertex, it's a little on the long side. So here we go. So so the vertex formula. The way you calculate the vertex is you take your equation. In this case, it's 1/2 x squared. Now, the rest of the equation is something x plus something. And since there was nothing there, it means they were zeros. And the formula is always going to be something x squared plus something x plus something. It's always going to follow that pattern. And in this case, our first something is a half, our second something is a 0, and our third something is a 0. And so instead of using the phrase something, we're going to say A is 1/2, B is 0, and C is 0. So there's our somethings. We call them A, B, and C instead. Now the vertex formula, it's a little it's like multiple steps. So the first thing you need to do is you need to find the x value. Because remember, if you're looking for coordinate points, you need to find the x value and the y value. Now, of course, we know that the answers are going to be 0 and 0, but let's use the formula. So the formula is negative b over 2a. And you're going to have to write that down. You don't need to memorize it. It's open notes test. So negative b over 2a. So what does that mean? Well, negative b, in this case it's 0, so it's going to be negative 0 over, and then it's going to be, this means 2 times a. So this means 2 times a. Well, we don't have to do any work because we know 0 over anything is 0. So we automatically know that the value for x is 0. So now, once we know that the value for x is 0, you go to your original equation, y is equal to 1/2 x squared, and we take that value of x, which we know is 0, and you substitute it in. And you just put it in there. So that becomes y is equal to 1/2 times 0 squared. Well, that's 0 times anything is 0, so this equals 0. So that tells us that the y value is 0. So if the x value is 0 and the y value is 0, that tells you your vertex is 0, 0. And that's what we knew all along because we used Desmos. But if the answer isn't a perfect number, if it's some sort of fraction, you're actually going to have to do the mathematics and calculate it. So that's why we have this beautiful formula in case we need it. All right, so I'm going to go over here. So now we know that the axis of, so we know the vertex is 0, 0. Remember what the axis of symmetry is. The axis of symmetry is the mirror, that line of mirror. All right, and so that happens at 0, at x equals 0. So the axis of symmetry is at x equals 0. All right, and so that's way over here. This guy right here, x equals 0 is our axis of symmetry. And then we're going to graph it. So you can use the graphing tool to graph it. That's pretty straightforward. But now we have to find out the values of f of -4 and f of 3. So you got a couple of ways to do it. One way is to look at the graph. F of -4. So if you look at f of -4, well, here's -4. So we're going to go straight up. And if you go straight up, you can see it looks like it goes right there, which appears to be 8. So f of -4 looks like it's 8. Now how could we be sure? Well, the way we could be sure, I'll put down it looks like it's 8. Well, the way we could be sure is we can take our function f of x equals 1/2 x squared, and we can substitute in the -4. So that becomes 1/2 times -4 squared. And so this becomes 1/2 times 16, which is equal to 8. And so that's how we know that the answer is 8. And if we want to figure out f of 3, well, a couple of ways to do it. One, we can go over here and look at our picture. And we can see that, well, 3, 1, 2, 3, appears to be right here. So we just kind of go up. Now, we got a problem here because f of 3 is clearly not a perfect number. So if we keep going, it's not an integer. It's not a whole number. It looks like it's going to be some sort of fraction. It's going to be a half. But we don't know that. So what we're going to do is we're going to go over here and we're going to take our little function, which is f of x is equal to 1/2 x squared, and we're going to take our 3 and put it in for x. So that becomes 1/2 times 3 squared, which is 1/2 times 9, which equals 9/2. And 9/2 is equal to 4 1/2. So they probably, because this is college, will take 9/2 as our answer. All right, so a lot of work on this one question, and now we're going to just do that for a variety of problems throughout the rest of this video. All right, first thing we're going to do is we're going to graph this. Well, how are we going to graph it? Well, the nicest, most beautiful way, let's use Desmos. So when I go over here and I type in, okay, I get, now I did something a little different because I want to show you something kind of cool. So the idea is you got this basic graph. It's y is equal to x squared. All right, now this basic graph, y is equal to x squared, is going to look something like it's going to start at 0 and it's going to go up and then it's going to go up. All right, so this right here is your basic equation. Y is equal to x squared. It's like your home equation. It's the mother equation. And then the idea is when you add 6, what does adding 6 do to the equation? Well, it turns out, what does it do to the graph? It turns out it slides it to the left. It slides it to the left because, how do I know? Because the red one is x plus 6. So when you add 6, it actually takes your equation and slides it to the left, which to me is counterintuitive. That's backwards. So when this says add 6, it means it's shifted to the left 6. And then I put it back at the home. And then when it's minus 2, you'll notice that's the blue one. Minus 2 means it's shifted to the right 2. Because you'll notice down here, this is negative 6 down here. And you'll notice over here, this is positive 2. And so when we have those, that kind of tells us when it's add 6, it shifts to the left 6. And when it's minus 2, you start at home, right there at 0, and it's shifted to the right 2. I think that's really kind of counterintuitive. So anyway, so we can see that our equation being x plus 6 raised to the power of 2 means the vertex is going to happen at negative 6. All right, so now that we know that the vertex is going to happen at negative 6, you can put in negative 6, and that will tell you where your point is. So we're going to do, okay, let's do, where am I going to do this? So the vertex, so first off, you'll see I graphed it, right? So anyway, the vertex, if we want to know the vertex, you just kind of go over here, you look, and we can see, well, the vertex is definitely right here at negative 6, 0. And if you wanted to do the math just to be sure, well, we can do that. You can say, let's take this original equation up here. So that's y is equal to x plus 6 squared. And if you want to know what happens when x is 6, you just insert, a negative 6, you insert a negative 6 wherever you see the x. And so you end up with 0 squared, which is, of course, 0. So y is equal to 0 when x is equal to negative 6. So our vertex, the vertex is at negative 6, 0. What's our axis of symmetry? X is equal to negative 6. All right, so that are the two parts for part B. Of course, part A we graphed by using Desmos. There's another way we could have graphed it, and I'll ignore that for a second. And then we're going to evaluate when f is negative 2. All right, so what are we going to do? We're going to take that equation, x plus 6 raised to the power of 2, and we're going to replace the x with a negative 2. So you get negative 2 plus 6 raised to the power of 2, which is 4 raised to the power of 2, which is 16. So when f is negative 2, when x is negative 2, y is equal to 16. Now we needed to know that formula because I'm not sure we can see that. So when x was negative 2, right here, when x is negative 2, and if we kind of kept going up the line, up the line, up the line, we're going to keep going up the line, up the line, up the line, and eventually, I don't know, it's hard to see. It looks like it kind of maybe crashes right here. At 16, it kind of gets a little crowded up here. So it's hard to see that the answer indeed is 16. Now, of course, if we want to know f of 3, you take the original equation, which is, whoa, x plus, oh goodness gracious. There we go. X plus 6 raised to the power of 2. And then you replace the x with a 3. So you get 3 plus 6 raised to the power of 2. So that's 9 raised to the power of 2, which is 81, which is way beyond my graph. So using the graph, using Desmos, that wouldn't have really helped. So in this case, you really did need the equation. So here, we're going to kind of go out of order. We're going to first graph it. And we're going to graph this equation down here. And we're going to do that using, of course, Desmos. Now, when we use Desmos to graph it, you will notice you get this kind of graph. And now there's ways you can stretch this out and make it seem a little wider and stuff. I don't know. I guess I just left it right here. But you'll notice we can kind of see where the vertex is. So let's zoom in to see where the vertex is. And we know that the vertex, the x value of the vertex is 0 because it's right here on the axis right here. So this being the vertex, it looks like the x value is 0. And it appears as though the y value, since this is -5, that means 2 further down is -7. So it looks like our vertex is 0, -7. Now, to be sure about that, what we're going to do is, I'll show you again that step. Now, what is our a value? So we're going to go up here and we're going to think about this. So this is 5x squared plus 0x minus 7. And that's your basic format. Something x squared plus something x plus something. In this case, it's a minus something because it's going to be negative. All right. So what does that mean? That means a is equal to 5, b is equal to 0, and c is equal to -7. So if we're going to find our vertex, the x value is -b over 2a, which means it's going to be -0 over 2 times 5. Where'd the 2 come from? Well, that's just part of the formula. Where did the 5 come from? It's a. And so you end up with 0 over 10, which is just 0. So the x value is 0. So now that we know that the x value is 0, we're going to take our formula, which is y is equal to 5x squared minus 7, and we're going to take our 0 and insert it in. So you get 5 times 0 squared minus 7. This is equal to 0 minus 7, which is equal to -7. So the y value is -7, and the x value is 0. So our vertex is 0, -7. And of course, that's what we saw all along in our graph, right here, 0, -7. But we have mathematically shown it. All right, now what's the axis of symmetry? Well, the axis of symmetry is x is equal to 0, because that is where your axis of symmetry is happening, right here at 0. And then what's the last thing? Well, now we're going to evaluate at f is -2 of 5x squared minus 7. And then we're going to do the same thing for f of 3. And we're going to substitute that in to the original equation. So I'm going to zoom in here. Actually, I'm going to get this guy away here. Okay, so now we're going to substitute it in. So you get 5 times -2 squared minus 7. So that becomes 5 times 4 minus 7, which becomes 20 minus 7, which is 13. So when f of -2 is, when x is -2, y is equal to 13. And then we're going to do the same thing with f of 3. So you get 5 times 3 squared minus 7, which becomes 5 times 9 minus 7, which becomes 45 minus 7, which becomes 38. So when x is 3, y is 38. And I think we've just done that whole section of the video. I mean, the whole problem. So it says we're supposed to identify the vertex and axis of symmetry, but first what thing I suggest we do is use our Desmos and graph. So when we go graph that equation, you get a frowny face, and that's because of that first sign makes this a frowny face. That first sign says it's going to be a frown. If it was positive, it would make it a smiley face, but in this case, oops, yikes, I want to delete, go away, there we go. Okay, so this first sign makes it a frown. All right, there we go. And so, but we can see that we've graphed it, and there's our graph using Desmos, and if we wanted to zoom in to see what the vertex is, it looks like it's pretty clear. The vertex is right here at 1, 1. But if we wanted to do the math to be sure that our vertex is 1, 1, we know that our formula, well, first off, we have to identify our A, B, and C. So we could see that A is -2, B is +4, and C is -1. And if we're going to use our formula, you've got x is equal to -b over 2a, which becomes -4 over 2 times -2, which gives us -4 over -4, which is equal to 1. So our x value is 1, and then our y value, you take the original equation, -2x squared plus 4x minus 1, and you substitute in the 1. That is x. You substitute that guy into here, and so you end up with -2 times 1 squared plus 4 times 1 minus 1. So this ends up being -2 plus 4 minus 1, which equals 1. So x is 1, x is 1, y is 1, so our vertex is 1, 1. And we knew that because it looked like it right here. All right, there we go. We knew it. Very good. So we've done the vertex, the axis of symmetry is x equals 1. We've graphed it using Desmos, and now I'm going to leave it to you to find the values, but basically what you're going to do is you are going to take your equation and you're going to substitute f of -3 into your original equation right here. And then you're going to do the same thing only with 2. So it's going to be f of 2, and that becomes into, you're going to put that, into your equation. All right. And there you have it. All right, so this one says find the maximum y value of this graph. So when you put this graph into Desmos, you're going to see that you've got your maximum right here. So what is that maximum? So if we zoom in, we know that this right here appears to be our maximum. And we see that this is, let's see, this is 10, and this is 15, so 10, 11, 12, 13. So we could see that the y, we could see that the y value is 13. So our y value is 13. I'm not entirely sure what our x value is. It looks like it might be 2, because here's our y-axis, 1, 2. But let's zoom down to find out, to make sure it's a 2. So I'm going to go all the way down here, and I can see that the line of symmetry goes straight down. And yep, I agree. I mean, it is. That's a 2. So the x value is a 2. So we're going to go up, and so our maximum value right here, that vertex, is 2 comma 13. And I would say we're kind of done. We don't need to do any more work. But if we needed to, so the answer is the maximum, what is the maximum y value? The y value is 13. All right, so if we wanted to, we could do the vertex stuff. We could say, okay, well, this is negative x squared plus 4x plus 9. So A is negative 1, B is 4, and C is 9. And then we can substitute and do x is equal to negative b over 2a and do all that work. And that would give us the answer. In fact, let's do that real quick. So this becomes negative 4 over 2 times negative 1, which gives us negative 4 over negative 2, which is positive 2. So the x value is positive 2. So now we're going to substitute that into our original equation, which is negative x squared plus 4x plus 9. And we're going to take our 2 and we're going to substitute it in. And so that gives us negative 2 squared plus, and then this becomes 4 times 2, and this is 9. And so you end up with negative 4 plus 8 plus 9. This becomes 4 plus 9, which is 13. So the y value is 13, and that is exactly what they're asking for. What is your maximum y value? And we now know it's 13, although we kind of knew just by looking at the graph. So again, we're supposed to be finding the maximum y value. Now, the thing that they did here is they're kind of tricking you around. They moved the order. It's really the best way to write it is in order of descending exponents. So really, this should be negative x squared plus 2x. And if we wanted to, we could say plus 0. So that means our a value is negative 1, our b value is 2, and our c value is 0. And we could do all that work to get the answer. Or we could simply type it into Desmos. So you'll notice I already switched it around. And if we're looking for the vertex, there it is. And we can see our vertex is right here. And it looks like our vertex is at 1, 1. So the maximum y value is 1. And that is your answer right here. Your maximum y value is 1. All right, so you can use logic. So basically, they're asking us which one of these graphs over here, which one of these graphs is the 1/7 x squared. Well, by process of elimination, we immediately know it's not going to be A, it's not going to be B, because we've been dealing with parabolas. Neither of those are parabolas. So it's either got to be this smiley face or this frowny face, and we automatically know by looking at the equation it's got to be the smiley face, because in order for it to be a frowny face, this first number needs to be a negative. So we're done. Now the other thing is, it asks us, well, how compare it to the x squared graph. All right, so the idea is, if your x squared graph is going to look like this, so that's y is equal to x squared, what is the 1/7 x going to look like? So what is y equals 1/7 x squared. Well, is it going to open up? Is it going to be a really slim? Is it going to shoot up really fast, or is it going to shoot up really slow? And when it's a fraction, that makes it shoot up really slow. So it's going to be a parabola that looks like this. If it was something like, oh, I don't know, let's do it in purple, and let's say y is equal to 8x squared, what that would do is that would make our graph look like this, like that. It just, our parabola would just be really skinny and it'd shoot up really high.